Throughout this module, we've talked a lot about REST APIs, and in this video, we want to consider how we can better secure those REST APIs. After all, we know that a REST API is going to give us a powerful and a programmatic way to access our network infrastructure. And in modern networks, we've got network controllers, automation platforms, orchestration tools that all rely on APIs. But here's the key concept I want you to understand. The same mechanism that allows you to automate thousands of devices, that also allows someone else to automate thousands of devices. And if an API isn't properly secured, an attacker might be able to read our sensitive data like configuration details, our IP addressing schemes, or authentication information. And even worse, they might be able to modify our configuration. Imagine someone pushing a malicious routing change to a router, disabling router interfaces, creating a backdoor for admin accounts. All that can be done using unsecured APIs. That's why security needs to be built in by design, not something we bolt on afterwards. And for the Encore exam, you need to understand that REST API security is not just about turning on HTTPS. It's about a layered protection approach. We need things like authentication, authorization, encryption, validation, logging, and a collection of best practices. So even though we love our REST APIs because they give us a lot of power, if they're not properly secured, they can be vulnerabilities. First, let's consider authentication. And authentication answers the question, who are you? And before an API server processes a request, it has to verify the identity of the client making that request. That client might be a script, it might be an automation tool, it could be an orchestration system, or even a custom application. And some common authentication methods include a basic username password combination. That's often used with basic authentication. That's what I used in the RESTconf demo we did earlier. We might have tokens like bearer tokens or session-based tokens. And from an exam perspective, we need to understand that if API authentication fails, then that API request is going to be blocked. The server is typically going to respond with a 401 unauthorized status code, and it's important to distinguish authentication from authorization, which we'll discuss next. Authentication is just verifying identity. It doesn't determine what the client is allowed to do. It only confirms that, yes, I recognize you. And without authentication, an API endpoint is essentially an open way to control our infrastructure, and that's just totally unacceptable in an enterprise environment. We always need to require authentication before any sort of API access. And while authentication tells us who you are, authorization tells us what you're allowed to do. Let's say that an API client successfully authenticates. That doesn't mean that they should have full access over the entire system. Instead, its permissions need to be carefully scoped. In most enterprise platforms, they'll use role-based access control, or RBAC. And with RBAC, permissions are tied to roles, not to a specific user. For example, there might be a monitoring role that allows read-only access, a configuration role that might allow editing, and above that, we might have an administrative role that allows deletion or system-level changes. So authorization is going to limit the scope of API operations. And why is that so important? Because if credentials are compromised, least privilege authentication is going to reduce the blast radius. An attacker that gets into a user's account who has read-only access, they wouldn't be able to push out any configuration changes. And even if authentication and authorization are configured correctly, there's another major concern. What happens while that data is in transit? Well, REST APIs, they use HTTPS, which means HTTP over TLS, Transport Layer Security, and that's going to give us encryption, integrity, and server authentication. For example, it's going to make sure that credentials are not exposed in clear text. They're going to be all scrambled up and encrypted. An attacker would not be able to intercept tokens or modify data in transit. And if API traffic worsened over plain HTTP, then an attacker, they could easily capture credentials using packet capture tools, and that would completely defeat the purpose of authentication. So REST APIs, they should never be exposed over plain HTTP in production environments, and HTTPS is going to protect us against eavesdropping and tampering. It encrypts both request and response data. And to sum up what we've said so far, we've talked about how authentication protects identity, authorization protects permissions, and HTTPS protects the transport. 3 separate complementary protections. Now let's bring this into the Cisco world specifically. A platform like Cisco Catalyst Center, it's going to use REST API security, and it should leverage the same core security principles that we've already been discussing. First, API access requires authentication. This is often token-based, where you authenticate once and receive a token for subsequent requests. Second, authorization is enforced through role-based access control. Your API privileges match your assigned role in the controller. And third, communication occurs over HTTPS, which gives us, as one example, encrypted transport. But Cisco platforms go a bit further. They also add an accounting function, meaning that they can log API activity. For example, we can see who made an API call, what actions were performed, and when were those actions performed. And having that accounting information, that can be a big help to us when we're trying to do troubleshooting. It can help us with compliance and forensic investigation after an event happens. And finally, let's talk about best practices. Even with all the built-in mechanisms that we've discussed, operational discipline matters. First, let's use least privilege access. API accounts, they should only have the permissions that are absolutely necessary to perform their function. We want to avoid using full administrative roles for automation unless it's really required. Second, we want to protect and rotate credentials. Hard-coded passwords in a script, that can be dangerous. And tokens, they should be stored securely. And credentials need to be rotated periodically to reduce long-term exposure. And third, let's disable unused API access. If an API endpoint or account is not being used, let's disable it, remembering that every active credential that increases our attack surface. And also input validation and sanitization. They're important to prevent injection attacks. We never want to assume that API data is trustworthy and properly formatted. So let's keep in mind that REST APIs give us a powerful and programmatic control of our infrastructure, but because of that power, they've got to be protected through authentication, authorization, encryption, logging, and disciplined access management. Automation and security, they need to go hand in hand.